In this section, we are going to learn microservices data management, choosing right database. So this is the first part of microservices data management that we will cover: polyglot persistent principle, the database per service pattern, the shared database anti pattern. We will learn relational and NoSQL databases, when to use relational, when to use NoSQL databases, best practices when choosing data store, and how to choose a database for microservices. And after that, we will learn CAP theorem, which is the consistency, availability, and partition tolerance. And after that, we will learn data partitioning, horizontal, vertical, and functional data partitioning. And after that, we will learn database sharding pattern, and we will also see Cassandra NoSQL database architecture for understanding the distributed database architectures. After this section, we have two additional sections related with the microservices data management, which are the commands and queries and distributed transactions. So with this section, we will continue to our vertical considerations of microservice architecture. If you look at the architecture design, you can see that we are on the third architecture style, which is the microservices, and also we are on the third vertical considerations, which is the data management of microservices. Microservices data management is really important topic, because since we are in distributed systems, we should have a strategy to handle data in several distributed servers. Every microservice has its own data, so the data integrity and data consistency should consider very carefully. According to our application requirements, we are going to evolve our architecture with considering these vertical considerations of microservices. We will discuss microservices data management topics with divided by three main topics. The first one is choosing the right database, the second one is command and queries, and the last one is distributed transactions. So in this section, we will focus on choosing the right database. That means choose the right tool for the right job. We will learn CAP theorem, horizontal, vertical, and functional data partitioning, and database sharding patterns, and so on. After that, we will learn commands and queries on microservices data management, that we will cover cross-service queries, join queries, CQRS design pattern, event sourcing, and eventual consistency principles. And lastly, we will learn distributed transactions on microservice data management, that we will cover saga pattern for distributed transactions, saga pattern for choreography and orchestration way, and also we will see the outburst pattern, and so on. Now let's start with the basics of microservice data management. So why we need to manage data in microservices? Because data creates many problems in microservices, and we need to solve these problems. So let's remember our problem. Databases creates bottlenecks when scaling. When we are designing e-commerce application with using microservices, one of the important problem is databases. Databases creates bottleneck when scaling. That means database becomes bottlenecks when we try to scale our microservice applications. Because databases are stateful services that persist data state in their systems. So if the application has state, then it is not easy to scale like stateless applications like microservices. So we should consider how can we scale stateful applications. So now let's see the problems. Problems are database are stateful services. Scaling stateful services are not easy like stateless services, and vertical scaling has limits, and we need to scale horizontally for our databases. As a solution, we can use these solutions. We can scale stateful applications horizontal scaling. We can apply service and data partitioning along business boundaries, which are the shards and ports. And we can also use NoSQL databases to gain easy partitioning features into our microservice databases. But this time we face another important questions when applying these solutions: how to choose a right database for microservices. So in this section, we will cover this question and learn solutions from best practices and patterns. Before solving this question, we should understand the fundamentals of microservices data patterns and principles.